Hello guys, welcome to part one of the Python and OOP Fundamentals Recitation. I'm Ewuzie Paul and I'll be taking you through this recitation. Now this serves to give you an introduction to Python and associated concepts that will help you get started in working with the Python language. And please note that this recitation is introductory and we expect you to leverage what you will learn here to build more competent skills in Python programming, even as you advance in the IDL course. Now, this tutorial is designed to briefly cover the following concepts: Python data types and associated methods, Python built-in functions, logical statements, looping, file methods, user-defined functions, errors and exception, recursion, and lastly, object-oriented programming, which is OOP. So we first start by looking at Python data types, the associated methods, and the relevant operations. Now, the first data type we'll consider is the numeric data type. And this data type consists of integer, floating point, and complex number. But in this tutorial, we're looking at just integers and floating points, as these are the most common numeric data types you will encounter in the daily usage of the Python language. Now, integers can be negative, they can be positive, as you all know. And here in this first set, what we're just trying to do is to assign these integers to these variables. And also you can assign floating point number, which are basically decimal numbers. So this variable, so here I've assigned 3.56 to floating one, which is a variable. And just like math, we can perform arithmetic operations, right, using these variables. So you can do addition, subtraction, division, and multiplication of these variables to get a new value, which is assigned to these other variables by the left-hand side, right? And these variables are also data type. The resulting values are also numeric data types as well. Now, Python allows you to also get the quotient of a division. So when you divide two numbers, right, you can get the quotient of that division. And you perform this operation using double forward slash, right? You also can get the remainder of a numeric division by using the percentage sign. So using percentage sign between two variables returns the remainder after a division, right? And then we print out these results using the print function. I'll talk more about the print function, but just know that it's a Python built-in function that helps you print to the console. And yeah, I've just printed the results of the results of the operations we did earlier. Yeah, so the next data type we are talking about now is strings. So string is also a very important data type in Python. You can create a string by using double quotation or double quotes rather, or using single quotes. Here, I created a string using double quotes. IDL is a font course, and I put it in double quotes. Here, this is a number, but when you put the number between single quotes, it makes it a string. He has also created a string. So we use backslash, like in most programming language, to escape the normal function or the normal function the quotation performs. So normally quote is meant to show this is a string, but then I want quotes to be part of my string. So I'm using backslash to say that this is taken literally rather than using it as a function, right? So it's just the same literally. So when it's printed out here, you see that the quotation marks are in my string, showing that because I've escaped it using the backslash. Yeah, so with the string data type, we can perform different operations. First, we can actually index. So if you have a string, like ideal is a font cross, and you want to get the characters, individual characters, you can do that by indexing. One thing you should note about Python is that Python is zero-based indexing. So the first character in ideal is a font cost is I, and the index is 0. The next one, D, is index 1, L is index 2. So I want to get the first character here in this string 1. I just need to use the 0 index between this in the square brackets, right? And if I want to get the top character, I use 2. Now the last character in a string, we use a -1 to represent the last character in a string, and a -2 to represent the second to the last character, so on and so forth. So getting the last character, you just need a -1 here to say you're looking to get the last character in a string. We can also get like range of characters. So here I'm getting from 0 to the 5th character. But remember, when you use 0 and 5, it is exclusive of 5. So 0 to 5 gets you the 0th index character, the first, the second, the third, and the fourth, excluding the fifth one. Right? So here, when you do 0 to 5, you get IDLI. So this is the first here, second, third, fourth, fifth. But in the reasons is the 0th index, the first index, the second, third, and the fourth index. So it stops at the fourth index, right? And also you can get the last three characters by using -3. When you don't specify anything in the second part, it signifies to the end. So it starts from the negative third character to the end. So negative third would be the third to the last character to the end of the character. So it gets the last three characters in the string. Now you can use length, that is length function, to get the length of the string. That's also another Python built-in function. Length gets you the length of the string, including it counts everything in the string, including the spaces. So the space is also seen as a character in the string. You can use split. Split is a method as well on the string to split the string. So when you don't pass in anything between these parentheses, normally it's supposed to take a delimiter, but when you pass nothing, it's going to split on the spaces and returns a list of those values. So splitting IDL is a fun course, returns IDL is a fun course. So it's splitting on the spaces in IDL is a fun course and returning the individual items. So when you pass in S, that small letter S, now remember it's case sensitive. When you pass in letter small s, it splits on S and returns IDLI. Remember, its IDL is a fun cross, so it removes the S here. Let me show. So you remove the S in this IDL is a fun cross and returns IDLI, then space a fun cross. So which is what we see here. Here, IDLI and a fun cross. Remember, there is a space here, so it does not neglect the spaces. It splits on the S. Yeah, so another thing we can do is that we can convert from lower to uppercase and upper to lowercase. So you just need to call the lower method on the string or the upper method on the string, and this converts the string to lowercase or uppercase. We can also add strings together. When you add strings, you are basically concatenating the strings. So it joins whatever is in string 4 to its is, and then joins that to string 5. So joining those things together, you see that it gives you I love idea. It's a fun and amazing course. And it's fun and amazing. So we can also multiply a string by a number. What this basically does is to take the whatever is in this variable string, the string in this variable, multiply it 3 times, and then concatenate it together. So we know str4 contains I love idea course, right? This here. So when you multiply by 3, it just does it 3 times and concatenates it together. So you have I love ID of course, I love ID of course, I love ID of course 3 times. Yeah, so the next data type we're going to talk about is the list. So a list is another data type in Python language under the sequence data type. Now the list data type is mutable, is ordered, and is changeable. So ordered means that the items in the list have defined order, which do not change. Right? So the items in a list have a defined order and it doesn't change. And we create a list by using square brackets to enclose a bunch of items, which are separated by commas. Now, one thing you should notice, the list is we use square brackets here, and then we add items in a list, and then we separate by commas. And a list might also be empty such that there's nothing in this list, just like 2 square brackets and nothing in between. But here we have defined a list with a bunch of items here, 1, 2, 3, 4, 5, 6. And so there are 7 items in this list. And one thing you should also understand is that a list can contain data types of different data types. So here we have integers with floating points data type, right? Here we have just strings. And in this other one, we have strings with other integers or floating points as well. And here we even have a list within a list. So you can have a list that contains a list. So this is a list, and is recognized as an item in this outer list here. Right? This is also a list within this main list. So the operation you can perform with list is that one, you can add 2 lists together. When you add two lists together, it just combines the items in this list, in list 3 and list 4, and creates a longer list, right? It creates a list that contains those two, the items in both lists, right? You can also extend the list. So you have list 2, you're extending with list 1. So what it does is to add everything in list 1 to list 2. So everything here in list 1 goes to list 2, and then your list 2 becomes longer, right? Containing both whatever was in list 2, including what was now in list 1. And just like we have explained with strings, you can also index. So if you want to get the first item, use 0. You want to get the seventh item, you use 6, right? Because it's zero-based indexing. If you want to get the last item, as we said, you use -1. Second to the last item, you use -2. And you can also get range of items, like we have stated, we're using when describing the string data type. Now, we also can do an append. Append function is append method is just adding a particular item to the list. So we have defined this list 2 here, and we just added Google to this list by using the append method. So you're going to just add Google as an item to this list. We can also remove from the list. So here we are removing Sam. So it removes this Sam from this list. What else can we do? We can also insert at position at the particular index you are inserting Amazon. So at index 1, we insert Amazon. And we also have the count function or the count method. So it counts the number of times a particular item appears in a list. So here we are counting the number of times list 6, Microsoft appears in list 6. Here it just appears 3 times, right? So here we've just printed out our results. You can go through it to confirm knowledge. Now, one thing we can also do with list is that we can reverse the list. So we are reversing list 7. So this contains blue, green, and yellow. And reverse just simply changes the order of the items. So you have yellow, green, and blue when you reverse, right? And you can also check if an item is in a list. So here we check if blue is in list 7. So it returns a true or false. So this statement here returns true or false. So if blue is in 7, it returns true. If it's not in 7, like here now, red in 7, in list 7, it returns false because red is not in list 7. So next we go to tuples. So tuples are ordered immutable data type. So that they are immutable in the sense that you cannot add items to a tuple, neither can you delete an item from a tuple once you have created them. Now they are created using pair of parentheses, enclosing a collection of items separated by comma. Now we can also, so here we created a top 1, just list of items. As I said, the list, just like you use parentheses in this case. The items does not necessarily have to be of the same data type. Here we have an integer or numeric data type with a string, which you have assigned to top 2. There's another way of creating lists. We can create creating tuples rather. We can create a list of tuples from lists. So here we have 3 lists, and we want to create a list of tuples from these 3 lists. So, but one thing you should notice is that the lists must have equal lengths, right? So what you first do is to zip these 3 lists together, and then I just use list to convert it to a list so that we can print it out. So when you zip these 3 lists together, what it does is that it puts all the corresponding indexes in one tuple. So here it takes Peter, it takes Nigeria and 22 and puts in a tuple. It takes Sandra, USA and 23 and puts in a tuple, so on and so forth. So when you print this, you actually have Peter, Nigeria, 22 as a tuple, this as a tuple, this as a tuple, this as a tuple, right? So we can create a list of tuples using the zip, right? And then I forgot to mention the zip is also a Python built-in function. Now here we just basically printed out. So since the tuple is immutable, that means it's hard for it. You can't change the items in it. So it limits the number of methods or operations you can carry out with the tuple. You can carry out the count like the one we've seen with the list method. With list data type, you can do the same with tuple. You can count. You can also use this dot index, right, to get the index of an item. So here we try to get grade, the index of grade in this tuple, and it returns 0. So it turns out grade is at index 0, right? Now next we go to set. Now a set is another data type which is unordered, immutable, and unindexed. Please note that a set being unchangeable does not restrict you from adding or removing items as with tuples. Now, a set is created using curly brackets and contains only unique elements. That is, it does not allow duplicates. So if you attempt to add duplicated items to a set, the set simply removes it and returns only unique elements. Here we've created a set, right? Just to illustrate, we created a set with these items, and then from here you can see we have two yellows, we have two blues, but when you try to print this set, it just returns single instance of those items. It neglects, or it just removes the duplicates, and it just returns only the singular instances. And like I said, it's unordered. Here you see that blue appears before white in the definition, but here see white is appearing first. So it does not have a particular order. So it's unordered, and therefore you cannot really index. We'll talk about why you can't index later. But you can't index here because it's unordered. Every item does not have a specific index like we have with lists, right? Or with tuples. Now, so you also create a set from a list. So if you have a list like this, you can just use a set casting. So you can cast with a set, and then it converts this to a list. It removes all duplicates as we have stated, and it just returns you unique items in that list. We can use the add method to add items to a list, just like we can append to a set rather, just like we can append to a list, right? So we can add to a set as well. So when you try to index, here we are trying to get the first item. It says set object is not subscriptable, which is what I was saying, that you can't index a set because it's unordered. It does not have a specific order. You can print the set now, it shows you white as the first element, and you print the next and it's showing you blue as the first element. So it's unordered, right? So you can't index to get an item from a set, just like you can do with a list. So next, you can also check out other methods, other set methods using this link, right? It has other methods like remove, like other methods that operations you can perform with the set data type. So the next item we look at, the data type we look at is the dictionary. Now, when we talk about dictionaries are very important in Python. They help in storing collections which have a key value pair. This is similar to JSON data type for those of you that have worked with JSON data type, and it's quite useful in storing information, right? So a dictionary is ordered and is changeable collection, which do not allow duplicate keys, not values now, just the keys. We'll talk about that. Now, a dictionary is written with curly brackets and have a key and value for each item pair. So you want to create a dictionary. We basically use curly bracket, just like with sets, but the difference is that each item in the dictionary has a key and a value, right? Here, the key is name, the value is Alice. We have another item that the key is age, the value is 16. So the keys can be of different data types. Here, the key is 3, and the value is accountant. Here, the key is string, the value is a list. So it's very flexible. It's very flexible. You can use different data types for the keys and the values. And here we just printed out the dictionary. Now, to get the key value pair or the value in the dictionary, you have to know the key. So here, when you subscript the key name, like because key is name is a key here. So when you try to get the value of name, right, you subscript using the key, and then you can get Alice. Right. So the same thing we printed here. We try to index, or rather, this is not indexing now. It's just trying to get the value using the key. So you use the key within the square brackets, and you get the value. So the value of 3, right, is accountant. So it prints accountant. Now you can also update a dictionary. So here we are adding a key called married, and we are assigning yes to it. Here we are creating a key called name. Remember, our dictionary already has a name, right? And it was Alice here. Name Alice. So here, when you try to pass in Susan, right, to the name now, what it does is to update the name with Susan, because like I told you, it can't have duplicate keys. So since it already sees that it already has a name key, it just updates the value. But when it looks for married is not in the list of keys. So it adds married and adds the value as yes. Now you can get all the keys in a dictionary by just doing dict.keys. This returns all the keys. Here I've returned all the keys, right? And I just use list to make it a list so that you can print out. Now we can also get all the values, right? So if you don't cast it with a list before printing, so it appears like it just shows you that it's dictionary values. So these are all the values in dictionary. And here, what I did was just to get the items. So the items returns a list of tuples. So when you use dot items on the dictionary, it returns a list of tuples, each containing the name and value. So each tuple contains the key and the value. Sorry. Here, name is the key, Susan is the value, age is the key, 16 is the value, and so on. So next, we now go to, we talk about Python built-in functions. And like these are functions basically that are defined by Python to perform specific tasks on different data types. Now, while going through the data types, we have mentioned some of those functions, such as the print function, the length function. We'll just look at some of these other built-in functions, such as the max minimum function. Here, the max minimum function basically just takes in an iterable, a list, a tuple, a set, and returns the maximum value in that data type or in that iterable. The minimum returns minimum value. And we have the type function. The type just tells you what type that variable you pass in is. So here we pass in list one, it just returns that okay, list one is a list. We pass in top one here. It turns out top one is a tuple, and so on. Next, we have the range function. Range function is very important. It helps to create a list or a sequence of numbers. So the range function takes by default it takes just one argument, but most times you can specify two arguments. The first argument tells it where to start from, and the second argument tells it where to end. So this will create a list, a sequence of numbers from 1 to 20, number before 20. So here it is 20 exclusive. So if you specify 20 as the end, it doesn't add 20 to the list of number it generates. Now, if you give it three arguments, it considers the third argument as a step. So if you have a list, you want to create a list between 1 to 40, but at a step of 2. So it counts 1, then 3. So it takes 2 steps and counts the next number. So 1, then 2, 3. Prints 3, 4, then 5. So it skips one number. And remember, since it does not add the end number, so it stops at 39. Right. You can also check out other built-in Python. There are a lot of them. You can check it out using this link. I've attached that to the notebook. Now, logical statements. Here we talk about logical statements. So logical statements basically return true or false, and it tries to perform some tests based on an operator. So the common logical operators have been listed here. Double equals to means equal. We're trying to check whether two data types are equal, not equal. We have less than, greater than, less than, or equal to, and so on. So just to test, here we have defined some data types, some variables rather. And here we have used the if keyword to create a logical condition. So here we are conditioning saying that if this is true, right, do this. We see how this is indented. In Python, use indentation to show that the statements are inside an if block. So you're using indentation to show that this statement is inside the if block. So if this is true, this statement will be done, right? We sound like this elif. Elif is basically else if. So in Python, the keyword is elif to show else. If this is true, do this, because this is indented. It means that this is under this else if statement, and so on. So we have range of else if, so you get your final else, just like in normal Python languages, in normal programming languages. So this is seen as one whole if else statement. And just to mention, an if statement might not have an else if or an else, right? But yeah, it must not necessarily have else if or else, right? And just be like one singular if statement, and that's just it. So once an else if statement is performed, it doesn't go further to check or test other statements, right? Once it performs an else if and it is true, it just does that and it leaves this if else block. It just goes out of it because this is seen as one if else statement, right? So we also have some logical operators like the and, the or, the not. So the AND basically joins two logical statements together. So it checks if this is true and also this is true before performing these operations. Remember, the indentation shows that these two statements are within this if block. So it performs it if this is true. Same thing here. This is an else if. So if this is not true, it tries to do this. Right? We also have the or just make sure that one of them is true before it performs the statements that follow, right? Just like in programming languages. Now, we also have the in statement. We've looked at in statement when we discussed the list data type. It checks if hero is in this, right? In this statement. So this returns true or false. So if it's true, it does this. This is another if statement. So it will, after doing this, it will definitely do this because this is another if statement. This is an example of an if statement without an else if or an else statement. So it's a standalone if statement. But this if statement has an else to it. So this is whole if else statement, right? So this is basically just showing you examples of how you can use the if statement. You also have nested if. So you have an if statement inside an if statement. So this is an if statement, and then you have this nested if statement, right? If else statement. So that's basically it for if else statement, and that's the syntax we use in Python when writing if else statement. Next we look at looping. A loop is used for iterating over a sequence, and that is either a list, a tuple, a dictionary, a set, or even a string, right? Here we discuss the for loop. The keyword for looping here now is the for. I know many languages also use for the for keyword. So here we have an empty list, right? So we create a for loop to go through this sequence, range 0 to 10. Remember what our range function does? It creates numbers, a list of numbers. Here it will create from 0 all the way to 9. Remember, it excludes 10. And then I is going to take the place of each of those numbers. And when it goes into this, it performs these two statements. We use indentation to show that statements are within a block. So these two statements are within the for loop or the for loop block, if I'm allowed to use that word. So it's within the for loop block. And so for each iteration, it performs these two statements, right? So I takes in 0 the first time, and it appends to the list. We have seen append method, and then it prints the list, right? So it takes it takes 0 the first time, takes 1, takes 2, up the way to 9, right? Now, we can also loop through the items of a list. List 0 contains Euro, USD, GPB, AUD, CAD, and JPY. If we check from here, say this is list 0. So we can loop through each of these items, right? So for each item now in that list. So each time you go through, this item is going to take one item from the list, and it goes through all the items till we get to the end of the items. It gets to the last item in that list and prints them for each iteration. Here we simply use indexing, right? Rather than using the items themselves. And this is important when you want to also index from another list. And then you don't want to just use the items directly. You want to index from another list, right? So you can have like more than one list, and you want to be like taking one, using the index from each list. So here we have index in the range. So this creates a number sequence, remember, that's equal to the length of the list. And if the list had like 10 items, so it's going to create length of 10 items, that's range 10, it's going to create numbers from 0 to 9. And then index takes 0 the first time, then it's indexing on this list, returns the first item based on the index, and then prints to the screen. So this is basically another way to index a list or an iterable. Now we can also use while loop to achieve the same thing a for loop can do, but most likely people use for loop because for loop is quite easier and it helps to avoid like infinite loops, right? So while loop, you just check in for a condition and you're printing, right? Based on that, whether this condition is satisfied. And remember to update your condition so that you don't go to infinite loop, right? This is just incrementing the index function each time, index variable, sorry, each time. So for dictionaries, it's quite different. To look through a dictionary, you want to go through the key and the value, right? So you have the item.items, which returns a tuple for each item in dictionary. And the tuple contains the key and the value. So for each of those items, you want to assign the key, you want to assign the value. So for example, we have name and Susan, right? The first time it goes through the dictionary, it takes the name and it takes Susan. It takes name as key and it takes Susan as value. The second time it goes, the key now becomes age and the value is 16. So you can use that to do anything inside this for loop, inside this for block. And the next thing we look at is the enumerate. What enumerate does is that since we cannot index on the set, we can create indexes for the items in the set. So when you do enumerate on a set, right, it attaches an index to each of these values. So for white, it attaches 0 index to it. For orange, it attaches 1, 2, 3 till you get to the last item. So your index here will represent the index of white, and item represent the value white, right? So if you have this first one, your index is 0 and your item is white, and you can print that index that is 0 and white. When you print index, it will be 0 and the item white for the first iteration. And then you can use that index, like I said, to index another list, right? So you're indexing this list, you're returning the first item in this list because you're using index 0, so it returns 0. And then you do the same thing, 1 orange, and it returns the second item in this list, and so on. So next, one thing we want to discuss now is the file method. Now, file method helps us to read in files in Python programming language. The file is opened using the open function, and it takes majorly 2 arguments, which are the file name and the mode of the file, right? So the mode can be reading, writing, appending, or just creating a file. So in this tutorial, in this place, we are trying to read a file named test data type, right? Test data.csv rather. And make sure that this file, if you're using Google Colab, is uploaded here. So let me upload a file, the test CSV here. Quickly do that. Okay, so we have uploaded the file here. If you're using a Jupyter Notebook, just make sure the test data.csv file is in the same directory as your Jupyter Notebook. And then we use the open, as I've said, to open the file. And depending on what you want to do with the file, you set your mode. If you want to read from the file, you use read. If you want to append something, if you want to write, or if you want to just create a file generally, you use X. So when you use this method to open a file, you can use read lines to read all the lines in the file. And then you close this file after reading. And then now we can print the file lines. Those are the lines we have read in, using read lines. So you see that this first item here in this list represents the first line read, and it adds a new line character at the end. So literally adds a new line character after reading the lines. Right? So read the first line, adds a new line character. The same thing, read the second line, adds a new line character. Here what I just did was to create a list of dictionaries. So the dictionary contains the values for each line. So first of all, there you can open the file using this with keyword. The with keyword is also very important in file reading, because with helps you to open a file and read, and closes it for you without you explicitly closing it. So it's a very good method, and it's often used for reading files. So familiarize yourself with the syntax. So we open using with. So with open, you're opening this file and you're reading it. And this is let me say, basically the cursor that's going to be like going through the files at the time. So here we use read line, not read lines now. So read line just reads the first line. And when it reads the first line, we strip out the new line character, and then we split based on the comma. And then we use that as our dictionary keys. So basically, you don't really need to pay so much attention to the code logic here, but I just wanted to show you that how you can read files. So here I'm using read line to read one line at a time. And what I want to do is I want to use the first line to create my columns. That's like my keys. And then I subsequently now read each line. So after reading the first line, the cursor goes to the second line. So the next time I'm reading the second line. So for the second line, in the other lines that I've read, right? So this returns a list of the other lines, right? I am creating a dictionary and I am removing the new line character, splitting it in the comma. We've discussed split in strings because the lines be read as strings, so you can use string methods or you can perform string operations on them. So we are splitting with the comma, and then we are using that to create the values of our dictionary. Remember, we already have the keys here to create the values. So like I said, the code logic, you might just neglect that. I just wanted you to see how you can read line by line. So this one, you're reading line by line and using that to do something here, right? And after that, you can see that I've read in the file and I've put it in dictionaries, right? Here, I just index the first two items in my dictionary. So here we are just writing to the file. So the difference here is that here we see that we're opening this file, though we don't have this file. But remember that if you write to a file and the file is not created, it automatically creates the file for you and helps you write to that file. So now we are writing to this file. So see here, we don't have that file, but it's going to create that file automatically for me. And then I can just write to it, right? This is just code logic, but you can just write to it. I joined and then I added a new line character and I'm writing to that file, yeah? So basically, if I run this, if I run this code, let me first run this because I have to read in the file. And then if I run this, it writes to my file. So it automatically creates that file for me. So it creates the file and it writes to it. So next we go to user-defined functions. So user-defined functions, they are basically functions which are defined by the programmer most times to perform specific tasks. The def keyword, this def keyword here, def, is used to indicate a function definition followed by a name. That's the function name. Here, print something is my function name. Then parentheses. This parentheses specifies it's the place where you specify your arguments, which will be used by the function. And then we add a colon, and every other statement is meant to be indented. Yeah, I see the indentation to show that all these statements here are within this function. So indentation shows that these statements are inside this function block, right? So print something is the name of my function. Use a def keyword to define the function. And here I've just done some logic and printed some things to the screen. Now to use this function, I just need to call it. Now you call your function, add it to parentheses to show that it's a function, not a variable. So you call it using this, and it then executes this and then prints or then like returns what you have set as a return value. Here we are, remember return, you know that return statements are very important in defining a function. It shows the end or marks the end of a function. So without return statement, you have an error, right? So your return statement is very important. Here we just call the function by just using the name and the parentheses. Next, we define another function here with an argument called array. So this array we use it to do some things here, and we return a number. Here you see we've set some list to a number, and what we just basically do is to find the sum of the sum of all the numbers in this array, right? Array is just a variable name, right? That's something you should note. Just a variable name that we're going to use in this function, right? So we're just finding the sum of all the values in this array, and then we're returning that sum. So here we just call the function. So first of all, we define the array, and then we'll pass that array to this function. Remember, add numbers is the name of the function, and we are passing that array to it. And then what it does is to do all this and returns the number. Same thing with this function. We just defined the function, passed in an array, performed some manipulations to get the even numbers appended in this list, and then finally return that list. So this shows that you can also return iterables or like lists, like sets, like tuples. You can return that as well from a function. Something you should also notice that in this place, I used another function within a function. So here I've used add numbers. Remember, we have defined add numbers here, right? So I use the add numbers function inside this function, right? And then I return that number, right? So that's something you should note here. So you can use a function within another function. Here I just show that you can use two arrays, two arguments rather. Yeah. So you create that this is an array, this is a number. I'm trying to check if this number is in this array. And once it finds that number in that array, it returns true. So wherever your return statement is, that marks the end of your function. Once you get to that statement in your function. Once it gets to the return statement in your function, that marks the end of that function, right? So that's basically for user-defined function. Next thing we're going to look at is errors and exceptions, right? Errors are errors in Python. We have syntax errors, we have other kind of errors, but we have basically error, which is syntax error, and the other errors are classified as exceptions, right? Now, one thing you should know about why we are discussing these errors is for you to understand the different errors we have in Python language, and we can examine the sources of this error, which will also provide us measures needed, right, to avoid such errors. So like I said, in Python, we have two types of errors, which are the syntax error and the exceptions. As the name suggests, syntax error are basically errors that occur due to the wrong syntax in your code. And this is always the easiest error because it's always pointed out by the Python debugger. Right? Now, while exceptions are just basically syntactically correct codes, but lead to error during execution time. So your code is correct based on syntax, but then during execution time, you have errors, right? Maybe due to wrong arithmetic operations or maybe things that cannot happen, right? So this results to exceptions. So here I've illustrated the syntax error in print hello world. So here there's missing parentheses. You see how this clearly calls out what is missing. So you see that it's easy to correct this kind of error. Is here, there's no column, invalid syntax. So it's pointing to a particular place. There needs to be a column here. So this is a syntax error. But here you see that this error is first of all is an index error. So what's happening here? You created a list that contains the three items. You're trying to get the third item, right? Right, because index form is third item. But this list has just basically three so index four means what now? The fifth item, sorry. So, but this list just has only three items, right? So there's no fifth item to this. So when you try to index at 4, you are going to get an error telling you that, okay, the index is out of range. So the length of the list is not up to 4. So you can't get an index of an item in the fourth place, in the fourth index, right? So here we have a key error. So key error always arises using when you try to get the value based on a key from a dictionary, but that key is not present in the dictionary. So in this dictionary, we have 1 as key, 2 as key, 3 as key, 4 as key, but you're looking for a value attached to key 5, but there's no value for key 5, so you have just 4. So it's telling you that there's a key error with 5. So there's a key error. Here we have type error. Type error, this arises from when you're trying to perform an operation between two data types, but the operation between those data types is not possible. Like here, we're trying to do an addition between a number and a string, and it's trying to say that, okay, this is unsupported. Yeah, given that one is a string and one is an integer. Here also, we define the function. This function originally during definition does not take an argument. But when you try to call the function, you're calling the function with an argument. So this raises a type error as well. It's saying that this takes 0 position argument, but you gave it 1, right? So this is it really gives is intuitive. The debugging messages are intuitive. You can really find out where the error is. This just makes you to understand the kind of errors you can have with Python and what you should check out for. So this is also another type error. This is an attribute error. So this is a tuple. And you're trying to append to a tuple, but you can't really append to a tuple, right? You can only do that with a list. Yeah. And so that's why you to come up with this attribute error. So you are trying to use an attribute with a data type that is not a list, right? So we we also have some other errors which I've not mentioned here. They are listed. Check the documentation. You have the zero division error. You have the name error, and so the list is. If you check the documentation, you can get an exhaustive list of the different errors we have. One last thing I would like to talk about before we do is recursion. I will not really go deep into this recursion, but it's just some most programming languages have this recursive function thing. You can actually, so recursive function for people that don't know, is just a function that calls itself. So you basically call a function within itself. So here, one thing recursive function does is makes you to write very clean and good code. Like it saves you time. So here, when you try to do try to calculate factorials of numbers, and you try to use if else and maybe loops, it's just so messy. But when you use a recursive function as this, it's very short, concise, and it's clear. But most times, recursive functions, the logic is very difficult to follow, and that's why some people just opt to using the for loop and um, maybe some other methods, right? So I just wanted to show that the recursive function is also possible with Python. If you're familiar with it, you can go through this example and just see how you can create a factorial function by this function calling itself inside here, right? And then, yeah, with that, you can actually just calculate the factorials of number. So I think that's it for the part one of this recitation. Hopefully, I'll see you in the part two. Hope you've gained or you've learned a lot. I just encourage you to go through the workbook one more time, familiarize yourself with the syntax, and see what is obtainable using the Python language. Thank you guys for listening. See you in part two. Bye.